Hey guys, welcome back to Math Basaba. Before we start, do not forget to subscribe to my channel and press the like button. Today we are still talking about quadratic equations and how to solve them using identities. This is a reminder from previous videos. We talked about what are identities important to us, and today we're going to see how can we use the identity of sum and product to solve a quadratic equation without using a quadratic formula. Take a look at this identity. As you can see on the left side of this equation, we have two brackets. The factor x is a common factor in these two brackets, but the first one has a factor of a and the second one has b, and this is not common between these two brackets. On the right side, you can see the first term is x to the power of 2. The second term is the sum of a and b multiplied by x, and the second term and the third term is the product of a and b. It maybe sound confusing, but it's not. It's pretty straightforward, especially when we have all the signs positive. Take a look at the first example. We said that the constant term is the product of a and b, and the coefficient of x here, and do not forget to consider the sign of the terms. The coefficient of x is the sum of a and b. So let's dig a little. What are two numbers that the product of them makes 12 and the sum of them makes 7? Okay, let's see. You can use trial and error with all the factors that multiply to each other makes 12. For example, 1 times 12, 2 times 6, 3 times 4. In this case, it's pretty simple. We know that 3 times 4 makes 12, and 3 plus 4 makes 7. So we got our numbers that we wanted. So we have two brackets here. Our common factor is obviously x, and our a and b are 3, positive 3, and positive 4. Now all we have to do is to solve this equation. Okay, let's see. We have two factors that are equal to 0. One of them is x plus 3 equal to 0, x plus 4 is equal to 0. So the first root is negative 3, and the second one is negative 4. This equation had two real roots. Let's see this one. When our equation involves negative signs, we have to think a little deeper. First, we know that negative 15 is the product of a and b, and negative 2 is the sum of a and b. Let's take a look at the product first. It has a negative sign, so we know a and b must not have the same signs. One of them should be positive, one of them should be negative. What are some numbers that they can produce 15? We know 1 times 15 is 15, but there's no way for them to make negative 2 as their sum. What are the other numbers that makes negative 15? We know that 3 times 5 makes 15, but we don't know which of them can be positive and which of them can be negative. Take a look at negative 2. It is negative, so the greater number should have the sign as the same as the sum of the numbers. So when 5 is negative and 3 is positive, they can produce negative 15 as their product, and the sum of them is negative 2. So we found our a and b. Our common factor is again x, A is plus 3 and B is negative 5. Let's solve this equation. X plus 3 is 0. X minus 5 is 0. From here, x is negative 3, and from here, x is positive 5. This equation had two roots as well. Here is an example for you guys to solve. Do not forget to comment your answers, and thank you for watching me. See you next time.